So again, now we're looking at solving equations or writing equations, right, that are two-step equations. So for instance, we had to read the words and then try to figure out an actual equation, right? So this is where we're at. The current temperature is 17 degrees. Could be not so far off in the near future, right? And it's supposed to rise 3 degrees each hour for several hours. But they don't really tell us how many hours. Okay? In how many hours will the temp be 32 degrees? Okay? So, where do we start? What do those numbers in that problem mean? What is the answer of this problem? 32? What did you say? Does everybody else agree with 32? Anybody else think something else besides 32 is my answer? Now you're going to change it? Okay, what are you going to change it?
The answer will be the amount of hours.
Okay.
H equals 5.
H equals 5. Why?
Because 17, I have it in my head, but I can't say it out. It's hard to say it out loud. 17 plus 15 equals
17 plus 15? Where's 15 coming from?
15 comes from 5 times 3 is every hour, and it equals 5 times.
So, how do I show that without putting a 5 in there?
17 plus H, 3 equals 17.
How's that? That make sense? 17 is where we're at right now. It's going to change 3 degrees per hour, but we don't know how many hours. And our final destination, or the high for the day, would have been 32 degrees. Exactly right. Now, do the problem. Figure out what H is. So again, now we're into the actual two-step equation process, right? This is what we did, heck, Wednesday of last week, I think. We had so much time off. So again, when we do two-step equations, cover up that variable part, and we're really looking at doing the backwards of PEMDAS. So we should look to add or subtract first, right? So in this case, we should have subtracted 17, right? Mm-hmm. And then we had our 3H equals 15. So H is 5, which the gentleman said. But because this is a story problem, it should be 5 what? Perfect. Don't forget that label, because now we're looking at a specific thing in story. Okay? So, the last thing that we have to do is, in some problems, you're going to have multiple things that are going to be asked in the problem. So, in some cases, the easiest way for most of these things to happen would be if you took and had different variables, added them up to your grand total. So, for instance, if we said that in here, the girls have raised more money than the boys for the walkathon, we could say that even though that we didn't know how much the girls saved, and we called it X, and we didn't know that how much the boys saved, which we could call Y, if we knew the total that you guys did together as a class, let's just say was $500, Could I do this problem right here if I knew that X was for the boys and Y was for the girls? Can I take and add X and Y together? No. Because I can never do a problem that has two different variables in it the way that we've been doing them lately, right? So what happens if I would tell you that the boys did 3 times as much as the girls? Would that make sense? If the boys did 3 times as much? Could you visualize that? Okay? So if I did that, I would want to take the variable that I had for the girls, which was Y, and turn it into the boys' variable, but use the information that the boys did 3 times as much as the girls. So if I came back and I said, this is my girls, and this is my boys, but the boys did 3 times as much as the girls, how can I write that using X for both genders? For the boys, right? So the boys did 3 times as much as the girls. If the girls did X, wouldn't 3 times X be more than what the girls did? Okay? So then, now can I do the problem? Can I take 3X plus X?
Yes.
Right? This is just combining like terms, right? What's 3X plus X? 4X. Because now instead of thinking of you as boys and girls, we're thinking of you as 7th graders. The 7th graders had 4X of 500. So then how would I find out what X is?
You divide by 4.
I divide by 4. What's 4 into 500? 125. So what does 125 mean?
That's 125. The boy.
125 is the what? How much the girls did, right? The girls did, because that's what X is. So the girls did $125. How much did the boys do?
3 times that number.
3 times 125. So how much did the boys do?
375.
375. Now, if I had both of these for the girls and the boys, did they add up to my $500? Yeah. But notice how I had to manipulate the problem. So both girls and boys, even though that they're totally different, had to end up being the same kind of person as a person to get to 7th graders. Okay, so I can never solve an equation when I have 2 different variables, right? I can't take a cow and add it to a horse. X plus Y's never work out. So in some cases, I have to manipulate the problem to change one into the other. And that's what we're going to try in the next couple. Okay? So, here we go. Let's do it this way, so everybody can see what the actual problem is. Sam collected 12 more cans than Louise in a can drive. Together, they collected 128 cans. How many cans did Sam collect? All right, so that's my equation, my story problem. So again, everybody's collecting cans, but I got Sam's cans and I got Louise's cans. Can I take an S plus an L and get my 128? No. So somehow I have to turn one variable into the other so I have the same variable. So here's the question. When I do a problem like this, I would start out by telling myself on my piece of paper, what does my variable stand for? Okay, but how many for which person? Does it matter if I pick X to be for Sam or X to be for Louise? Not really, right? So, somebody tell me who you want X to be. X equals Sam's cans, right? So, how much do we have together between the two of us? we definitely have a total of 128. Everybody agree with that? And Sam has X. And what are we going to do with Sam and Louise's cans? Louise's are going to be right there. What would we do between the two groups to get to 128? We would definitely add them together, right? So, how do I show Louise's cans with respect to Sam's cans? So here's the question. Before you answer that part, who has more cans?
Sam.
Everybody agree with that?
Yes.
How do you know that? 12 more cans, right? So if X is for Sam's cans and he has 12 more than Louise, how many cans with respect to X does Louise have? Louise, okay, she has 12 less, right? So how do I show 12 less than this X?
Like 12 minus Louise is like 12 cans.
Am I going to take
No, like
12 minus Louise's cans or 12 minus Sam's cans?
Sam's cans.
Everybody agree with that? How many does Sam have? He has X amount, right? And Louise has how many? 12 less than Sam's, right? So if this is Sam's, again, I'm saying that X is Sam's cans. Louise has 12 less than how many Sam has. So I got to use X in both cases. So again, when you get to one of these problems, you're going to have multiple variables in the problem. Multiple sets of variables. But you can't have multiple variables, meaning two different variables. So you have to manipulate the one variable to show the other person or other whatever amount of cans in this case, but it could be anything. So here's the question. If I did the same problem, but Colbeck says that X is equal to Louise's cans, can I still do the problem?
Yeah.
How does my equation change if somebody says X equals Louise's cans?
You have to add 12 instead of subtract.
Perfect. And so what would my equation be for the whole thing?
X plus 12 equals 128.
Everybody agree with that? So, here's the question. Am I going to come up with the same answers?
No. Well, yeah.
Some of you say no, some of you say yes. Who wants to agree with who? Carson says yes. Who's going to agree with Carson that you're going to come up with the same answers? You said no.
I know.
Grace says
I
no.
didn't think-
Why aren't we going to come up with the same answers?
Because in one of them you're figuring out Louise's amount, and then in the other you're figuring out Sam's amount.
Okay. Did everybody agree with what she just said there? What she actually said is exactly true. But is Louise's answer or amount going to be different in this problem than it is in this problem? So the actual numbers aren't going to be the same, but what we actually find are going to be different answers. Does that make sense? Okay, so let's do both problems. If I'm going to do this problem right here, remember, what was the things that we had to do in the order to do multi-step equations? What was the first thing that we had to do? Get rid of parentheses. We still don't have any. What's the second thing? Combine like terms, right? So up here, what's x plus x? So we get 2x minus 12 equals 128. On the bottom equation, the only thing that changes is what? The only thing that changes is the plus 12 on the bottom, right? Up here, how do I get x alone? Add 12. Remember, whatever I do on one side, I got to do on the other side. My 12s cancel out, same number but different signs. 2x equals what? 140. How do I get x?
Divide by 2.
140 divided by 2? 70. If I finish the problem over here on the bottom, I do basically the same thing, but the first step I would actually what? Subtract. My 12 still cancel out. I'm left with 2x is equal to what?
116.
And then I'm going to still divide by 2, so x is equal to 58, right? So why in the heck aren't these numbers the same?
Because you're figuring out different people's amount.
Because we're figuring out different people. So in this one, x equals 70 is what?
Sam.
This is Sam. So in this case, how would I find Louise's answer if I did the problem on the top half?
Subtraction.
So then I would take 128 minus Sam's 70, and I get what?
58.
But notice what we got in the other one, right? So this is where you got to be careful. If you're going to get help from somebody next to you, and you say, well, what was your answer? I got x is equal to 70. And Grace said, well, I got x is equal to 58. You're both right, but you're probably going to confuse each other, right? So the question that you have to ask before you give your answer is what? How did you do the problem? Who did you make the variable? Who was x in your problem? Right? Because if you didn't have the same person as being x, you're going to get a different initial answer, but eventually you would have gotten the same answers. And again, down here, we would have taken 128 minus 58, and we still would have gotten 70. That make sense what I'm saying? Okay. So, you got to use the same variable in two different places. One for somebody and one for somebody else, or one for something and one for something else. But they're going to have some kind of relationship, right? In this case, it was a difference of 12 cans. In this one over here, it was the amount of money that we brought in, right? 3 times compared to 12 more of it. Okay? So, the last one, I want you to try on your own. Luann is 5 years older than Cole. The sum of their ages is 37. So how old is Luann? So again, I don't care who you make what, but the question I want to ask before you start is, who is older?
Luann.
Luann, right? So keep that in the back of your mind. Try it out. See what you come up with. So after you convince yourself that Luann is definitely older, one, because it tells you that, the next thing you have to decide is who is represented by X. We get an answer? So again, the first thing that we ask is, who did you make for your variable? Anybody not make Luann X? And again, I might come up here and show myself, hey, X is equal to Lou. Right? Or X is equal to Cole. Anybody make Cole X? You did both of them? How's that? You did it both ways, you mean?
Yeah.
Oh, okay. So Miley did it as X is equal to Cole. So again, her equation will be just a little different, but eventually we should get the same answer, right? So Allison, what'd you come up with? What was your equation that you wrote?
X plus 5 plus X.
Everybody agree? Equals 37. If X is Luann, and she's 5 years older than Cole, this right here would represent Cole. This right here would represent Luann. Now, what changes in Miley's?
You would have to subtract 5.
The only thing that changes is that we have X plus X minus 5 in Miley's, right? Because Cole is 5 years younger than. So Cole, and this would be Luann. Luann is 5 years older than Cole, or Cole is 5 years younger than Luann. Either case, he came up with Luann being how much?
16.
And Cole is?
11.
Luann is 21, and Cole is how much? 16. Everybody agree? So, if you have Luann as being 16, and obviously Cole is 5 years younger, he would have been 11, but 16 plus 11 isn't 37. So then you got to know that somewhere I screwed up. So then I would have came back, and these two ages make a lot more sense. Okay? Everybody understand where we got it? Yes, no.
I'm still confused of how you figure out like what you write.
What I write. Okay,
Like this.
from what I write, it comes from the words, though, again. So, again, this is huge right here of telling yourself what is going to be X. Okay? If you went this way, so let's erase the cool part, because you did it this way, right? Yes? So, X is Luann, and Luann has to be older, right? So, if X is Luann, and she's 5 years older than Cole, we should have done it the other way in this one, right? Cole should have been younger, so this one should have been the minus. Maybe that's why you're confused. Did you have minus or plus here?
I just didn't really.
You just didn't do it. Fair enough. All right. So here, X is Luann. So we actually wrote this one wrong the first time. Luann is older, so Cole has to be minus 5 because he's younger than Luann. Luann is what X is. And that's where telling yourself this part right here is key. If you did it as X is Cole, okay, Luann has to be X plus 5 because she's 5 years older than Cole. So you just got to go through and you got to read the problem in the book or in the right order. And that's where we messed up. Let's see if we can find another one. Whoa, stay there. I can. Of course, they don't have another one like that. All right, let's try another one. Julius, or we'll just say Jewel, sold 5 times as many computers, I'm going to abbreviate, as Sam, in total, they sold 78, I believe it says. How many did they each sell? Okay? So again, when we have 2 different people, but we're doing the same process, trying to figure out the number of computers, we know that there's going to be two variables representing the same person. So, again, start out, tell yourself, who is X? Jewel. Okay? When they say in total, we're going to probably do what? We're going to add. So I know that I have to add my two people, and the total has to be 78. Would you agree with that? Okay? And you just told me that Jewel is X. Okay? So the other person is Sam. And Jewel sells 5 times as many computers as Sam. So does Jewel or Sam have more? Jewel has more, right? So how do I show that Jewel is 5 times as many as Sam? 5 times X. Does that make sense? Which part are you confused on? Why the 5 goes here? Or, you gotta help me out here, sister. Do you understand that we're gonna add the two people together? Everybody good with that? And this has to be my total. So now your problem is the other descriptive word, right? Well, if I told you that X, or if I was going to put this with Sam, I know that Sam has to be less than what Jewel is every single time. So the only way that I can do this is either, because it says 5 times, that's a multiplication person. But if I put 5 with Sam, and I take 5 times X, that makes Sam really, really big. Or his amount really, really big. But Jewel has to be more than him. So my only other way of doing this is picking the descriptive word and doing the opposite of it. So the opposite of times would be division. But if we start doing division in this problem, it's probably really, really confusing. So I want to avoid doing division. So you got to just read real slow and see who has or who should have more of whatever we're talking about. In this case, the computers. So in this case, Jewel has to be bigger. So the only way to make each variable bigger is to multiply by that 5. And if I'm going to multiply, that tells me that Jewel has to have that multiplication because he is or has sold way more than Sam did. We need to write down another one? Yeah. Anybody else struggling with what Grace is struggling with? Anybody have an idea for Grace that you guys could say that might click in Grace's head compared to what I'm saying right now? None of you can help Grace out? Nobody has a suggestion? Fair enough. Gary trained 32 more dogs than Xena. Okay. Together, they trained 126 dogs. Okay. So, once again, pick what X is. Gary's X. Who did more? Gary trained 32 more, right? Okay, so if he's X, and again, if they train together 126, what's that 126 tell us? that has to be my grand total of the number of dogs, right? So here's Gary. Here is, what was the other one? Zena. Okay. So, Grace, where's my descriptive word? More, right? Is more tell me what?
Addition.
This is going to tell me addition. Okay? So if Gary is X, what is Zena compared to Gary? Is she more or less than Gary? She's less. So even though that this says there was more dogs, we're talking about Zena now. And Zena is actually less. So when I'm talking about Zena, that should tell me compared to Gary, which Gary is X, she did what?
Less.
She did 36 less than what Gary did. 32, sorry. Does that make sense? So if you said X was Zena, then you would have had X plus 32 because he was more than Zena. So that's maybe where you're getting confused. Sometimes, even though that the descriptive word was plus, and you set it up where the person was actually the opposite, then you got to change the descriptive word. And I think that was maybe what was confusing. So you see where Gary was the bigger one, so that tells you have to subtract from Gary 32 to get what Zena was. Does that help a little bit? Okay. These are a little bit kind of weird in the head sometimes. Okay. Does anybody have any problems of solving it? It's just setting those ones up kind of a little bit, right?
Would you add the X and the X first?
Yep. Yeah. So I'm going to say 6x is equal to 78. Then I'm going to divide. So x is what? 13. So if Sam did 13, how many did Jules do? 13 times 5. Because it was 5 times more, right? Over here, I would have done 2x, right? I'm going to combine my x's minus 32. So how do I get x alone?
Add 32.
Add 32 first. And now, divide by 2. So x is equal to, what's 158 divided by 2? 79. So, how many did Zena do? And do these two numbers add up to 126?
I found another way to do it.
Shoot, tell her.
So you take 126 divided by 2.
126 divided by 2. Which would be 63.
Then you add 32 to 63 and then subtract 32 from 63.
Okay.
Then you take then so
Now I'm going to subtract 32.
yeah, subtract 32.
Okay.
I had it.
I'm not going to lie to you, Grace. That might be more confusing than mine.
It's confusing, but it got the answers.
Well, yeah, so did mine. Hey, if it works in your melon, you do it that way. Okay? As long as it works, exactly right. All right? So, in the last ones, you just got to go a little slower. And really, don't forget at the very end to check. if I had this case, I know that my answer has to end up being 126 between the two people. So just make sure that that works out. Okay? Again, don't get frustrated with this. Go slow and ask for help. And we'll sit down and read through them together. Okay? Or read through it with one of the others in here. Again, they might have a little something besides Caleb.
I have it.
That, now you have it?
Yeah.
We'll talk about that later. Sit and talk with somebody else in here, though, and see if they can explain what you're trudging through. Because again, it could just be the way I say it. They're probably going to say the exact same thing, but you might just understand them a little bit better because you talk their language. Sometimes we don't talk the same language, and that's okay. All right? So, go slow.